Okay, I'm starting new topic, indefinite integral, and we are going to go over all possible method, main fundamental method. Obviously, it's not possible to explore absolutely all methods. There are too many, but the main ones we will go over. Um, so today I want to introduce indefinite integral. So indefinite integral is opposite to derivative operation, just like subtraction is opposite to addition, division opposite to multiplication. Okay, so and before we talk about integral, let's understand what means antiderivative, because indefinite um, integral is formed based on an antiderivative. Okay, if the function f of x, let me change this. If the function f of x, uppercase f of x, is antiderivative of lowercase f of x, then the f1 of x, that is equal f of x plus c, where c is a constant, and it can be any constant. Why any? Because since when we take a derivative of constant, it's zero, right? Now when we are going backwards, we have no idea what constant is there or could be, right? Therefore, we say this constant can be anything because we don't know. Okay, and it's a part of the antiderivative function, which is f of x. So since c can be anything, constant can be anything, that means the entire set of antiderivatives is going to be the specific antiderivative f of x and plus set of all kinds of possible constants. Okay, now the entire set of antiderivative with this specific antiderivative and constant that can have any value, we call indefinite integral of this function. We call indefinite integral of this function, and we mark as use red color, we mark as integral f of x dx. So when we want to take antiderivative or integral, this is how we mark f of x dx, and that is going to be f of x plus c. Okay, real quick, let me explain what is what. So f of x is our, we call integrand. F of x is integrand. Okay. Dx is a variable of the integration. Variable of integration. Okay. Uppercase f of x is antiderivative of lowercase f of x. Derivative of lowercase f of x, and c is a constant of integration. Okay, so the whole this expression, integral f of x dx, we read as a antiderivative of f with respect to x. So the differential dx serves to identify our x as the variable of integration. And we call all this, we call the indefinite integral, which is similar, but it's more general form because it includes all possible the constant in there. The process of finding indefinite integral we call integration of function. Therefore, the problem of integration of function, it's coming down to the finding of the antiderivative of the problem. Okay? Also, it's very easy to check the result of integration. All we have to do, take derivative and see if we get the problem under the integral. Okay? So before we start solving some basic problems, I would like to show you basic integration formulas. So, if derivative of constant, let's say d by dx of c is equal 0, then integration formula, it's going to look like 0 dx is equal c. Okay? So, if we have d by dx for kx is equal k, right? For example, 3x derivative, it's going to equal 3. Then, integral of k dx is going to be equal k x plus c. So which means from here we are coming backwards. If you want to figure out how to write down integral, you go backwards from here, integral k dx. Where from dx? So d by d of kx, right? From here I can write down, let me see, d of kx is equal k dx. And this piece goes under, look, under integration. Okay? Next. If we have derivative of function with a constant, so d by dx of k f of x is equal k, and since we don't know what function is about, we put f prime of x, yes? Which means, so what we are doing, we are going to take this under integral, it's going to be integral k f of x is equal, integral comes out and this f prime of x stays under integral, right? F of x dx. For the derivative with chain rule, so if we have d by dx, x to power n is equal n times x to power n minus 1, then integral of x to power n dx is equal, so it's going to be opposite, right? If it was n minus 1, it's going to be x to power n plus 1. It was n to power plus 1 minus 1 multiplied by n. Then here we are going to divide by n plus 1. Okay, n plus c. So we need to make here note that n cannot be equal negative 1. Otherwise it will be division by 0. This is what we call power rule, the rule, right? Okay, and the other, there are so many formulas for integral. We will slowly get familiar as we start solving. So let's assume our integral is 1 over x cubed dx. So this type of notation I would rewrite in the format of x to power negative 3 dx because it's easier to solve this way. And then I would apply the integral for the chain rule, this one, right? Because here we have chain rule of derivative, so I would apply the integral that solve the chain rule, which is going to be equal x to power negative 3 plus 1 based on this formula, and dividing by negative 3 plus 1 and plus c. We don't forget c. So which means if I simplify, it's going to be x to power negative 2 over negative 2 plus c, and as a result we are getting negative 1 over x squared, 2 here, x squared plus c. Okay, another one, square root x, integral of square root x dx is equal integral of x to power half dx, right? And that is going to be equal. So if I take x and here 1/2 minus 1, plus 1, divided by 1/2 plus 1 and plus constant. So in this case we are going to have 1 and plus half, it's going to be 1/2, or it's going to be 3 over 2, right? And divided by 3 over 2 plus c. And from here I can rewrite 2/3 x to power 3 over 2 and plus c. Okay, and let me solve another one, simple one, before we start solving using methods. So 2 sine x dx. So what is the derivative of sine? Is cosine, right? So it's going to be 2 will come out. We will have sine x dx. Okay, now let me write down the formula for integral sine x. So let me ask you this question. Sine x is a derivative for which trigonometrical function? It's going to be derivative of cosine, right? It's going to be d by dx cosine x is equal negative sine x. Yes, and from here, if I have derivative of sine x dx, is equal negative cosine x and plus derivative, right? Let me pull this a little bit. Okay, now let's get back to our problem and see what we're gonna get here. So we're gonna get the following. It is gonna be equal, sine is gonna be equal to negative cosine x plus c, which is going to be equal negative 2 cosine x plus c. Okay, let's solve next one, a couple of easy ones, and then we'll start using methods. So let's get warming up, get familiar with the integrals, indefinite integrals. All right, let's now try to integrate polynomial functions. So we have dx, right? That means we understand 1 dx, yes? If we have 1 dx, what does that mean? That means we have x to power 0 dx, right? If we have x to power 0, then what property we can apply? Derivative of x to power n dx is equal x to power n plus 1 over n plus 1 plus c. Okay, so this is gonna be, rewrite. So this is gonna be x to power 0 plus 1 over 0 plus 1 and plus c, which is going to be equal x to power 1 over 1 plus c. Or I can take off plus 1 and just write down x, and without any degree 1 or any division by 1. Okay, next one. X plus 2 dx. So here we are going to apply the property of indefinite integral, which means this the integral of sum of the integral of sum is equal sum of integrals. So if we have integral f of x plus g of x dx is equal, let me squeeze here in so we will have space to write down. Okay, so it's integral of sum is equal sum of integrals, which is going to be integral f of x dx. My integral looks horrible. Trying one more time. Okay, a little bit better. Plus integral g of x dx. So integral of sum equals sum of two integrals. Okay. All right, let's apply this. It's going to be integral x dx plus integral 2 dx. Okay, x, we have power 1, right? Therefore, if I take integral of that, it's going to be x to power 2, because plus 1, and divided by 2, plus c1. Yes? yc1, because I will have another constant for the second integral, and it's going to be, since we have 2, so 2 meaning it's going to be integral, let me write down 2, I can write down x to power 0 dx. Okay, and that is going to be giving me 2 constant stays, and x to power 0 is going to be x to power 1, because 0 plus 1, and divided by 1. Yes? Or otherwise it's going to be just x. 2x plus c2. Okay? And from here, if we combine, we are going to get x squared over 2 plus 2x and plus c, where c would be equal c1 plus c2. Okay? Next. So, integral 3x to 4 minus 5x squared plus x and dx, and that is equal. So free stays, we have x to 4, it's going to be x to power 5, right? And divided by 5, minus 5 there is. X squared is going to be x cubed divided by 3. And we have x, it's going to be plus 1. It's going to be x squared over 2 and plus c. So as a result, we are going to get 3 over 5 x to 5 minus 5 over 3 x to 2 x cubed and plus 1/2 of x squared and plus c. Okay, let's solve next. So we have integral sine x over cosine x squared, entire cosine x squared, not just x squared, and here dx, and that is equal. So we want to rewrite this first before we solve it. So it's going to be, I'm going to break down this cosine square x as a cosine x and then times cosine x. So this practically combining sine x with this cosine x, and then the other cosine x, just leave it by itself, 1 over cosine x. Let's watch here. I'm going to do 1 over cosine x times sine x over cosine x, and all this goes under dx. Okay, so derivative, okay, well, let's change it a little bit, do some changes. 1 over cosine x is a secant x, right? And cosine by sine, it's a tangent x, right? Okay, now let's remember derivative of which function gives us secant times tangent. That's right, I hear you are saying secant x prime, which is derivative, is equal secant x tangent x. Therefore, we get from here secant x plus c. All right. Next, we will do some rewriting before we solving. Two over square root x dx. So I'm going to rewrite the following way. It's going to be 2 and x to power negative 1/2, because you have x to power 1/2 in denominator. You move up, become negative. So, and now once we want to integrate, we are going to get, this 2 is a constant, stay. Negative 1/2 plus 1, it's going to be positive 1/2, right? So it's going to be x to power positive 1/2 and divided by 1/2 and plus c. Okay? So if we simplify this, it's going to be 2 multiplied by 2 over 1, right? Because we are dividing, therefore when you divide, second fraction going to flip. And times x to power 1/2 and plus c. And the answer is 4 x to power 1/2 plus c. Next, integral t squared plus 1 squared dt. We are going to integrate by t. So it's going to be, we are going to rewrite t to power 4 plus opening parenthesis, right? We have a plus b squared. We just open a squared. It's going to be t to power 4 plus 2ab. It's going to be 2t squared and plus b squared, which is going to be 1 dt. Okay, this is going to be equal. We have 4, t to power 4. Then it's going to be t to power 5 over 5, right? Plus, you have 2t squared. 2 stays there. T squared is going to be t to power 3 and divided by 3, right? So, and then when we have 1 meaning nothing else but t to power 0. Zero, it doesn't look like 0. Okay, this time. So which means it's going to be plus 0 plus 1, it's going to be t to power 1 over 1 and plus c. All right? So it's a result. We are going to get 1/5 t to power 5 plus 2/3 t to power 3 plus t. This is t, not prime, but degree 1. And plus c. Okay, I'm done here. Next. Those are basic stuff. We are just getting familiar with integrals. X cubed plus 3 over x squared dx. Okay, how to solve this one? We can separate, divide x cubed by x squared and then 3 by x squared. This is what I would do. X cubed over x squared dx plus integral 3 over x squared dx, and that is going to be equal, this is gone, here will be 1, so that means integral x dx plus integral 3x to power negative 2 dx. Yes? And from here we have x dx is going to be x squared over 2 plus this 3 stays, comes out because it's a coefficient. Now x to negative 2, negative 2 plus 1 is negative 1 over negative 1 and plus c. This is going to be equal x squared over 2 minus 3 over x and plus c. Okay? Cubic radical x minus 4 dx is equal integral x to power 1/3 times x minus 4 dx. And then this is equal. So if I distribute, it's going to be equal. So let's do this drafting real quick. X to 1/3 times x to 1. It's going to be x to 1/3 plus 1. It's going to be x to 1 and 1/3, which is x to 4 over 3. Yes? Okay. So we have x to 4/3 and then minus 4 and x to 1/3 dx. All right. So from here, well, let's take antiderivative. X to power 4/3. So if I plus 1, so 4/3 is a 1 and 1/3, right? Plus 1, it's going to be 2 and 1/3, which is going to be 7/3. Okay, so we are getting x to power 7 over 3 divided by 7 over 3, right? Because we are using property, x to power n plus 1 over n plus 1. Okay, minus 4 times, okay, 1/3 plus 1, right? Here, taking derivative, x to 1/3 integral n dx is equal x to 1/3 plus 1 over 1/3 plus 1. So 1/3 plus 1, it's going to be 1 and 1/3, which is going to be 4/3. So 4x to power 4/3 and divided by 4/3. And result is, so 7 over 3 in denominator. If I flip over, it's going to go to numerator, get 3 over 7. X to power 7/3 minus 4/3. I'm going to flip it. It's going to be 4 times 3 over 4 when this is going to cancel. And I will have x to power 4/3 and plus c. Okay, so let me rewrite clean. Okay, this is equal 3 over 7 x to power 7 over 3 minus 3 x to power 4 over 3 and plus constant plus c. Okay.